Let us try to solve 3 challenging problems in complex numbers. Let's start with the first one. So we have here a operation, a fraction with 4 complex numbers. So we have 2 plus j5 as a rectangular form, and we have an exponential form here, the 8 um, ej 10 degrees. We have 2 plus j4 rectangular form again, and then we have a polar form to angle negative 40 degrees. So the first step, first and foremost, before you use your calculator, okay, call it numerical method, or you use your ideas or your analytical method, okay, so we need to transform the equation, convert the complex numbers into either rectangular or polar form. Okay, again, transform exponential and trigo form into rectangular polar form. So this is what happens. Okay, so this is the first step. Okay, so you have rectangular form and then you have the polar form. So basically the exponential, we transform it into polar. And here you can either use your calculator or analytical method. So first we solve using analytical method. So you can either transform the polar to rectangular to do the basic operations in product and getting the division or the quotient. Okay, so or transform the rectangular to polar. Okay, so then perform the basic operation. So there are many ways to solve this in analytical way. Okay, so what I did, we transformed the numerator into the polar, okay, polar form. So this is the modulus of this complex number 2 plus j5 is square root of 29, angle tangent inverse of 5 over 2. Okay, so we have learned this one from the previous lectures, how to do this. Okay, so basically the 2 and 5, getting the getting the sum of the square root of the sum of the square, or the Pythagorean equivalent of 2 and 5. We got this one polar form. Now in the denominator, because this is addition, so it would be better if we transform this one into rectangular form. But there's no one will stop you to transform 2 plus j4 into polar form, which is also okay. But um, it would be better if you transform the polar into rectangular because of the operation addition. Okay, so we have discussed that one also in the previous lecture video. So here we have this new form. So for multiplication of the numerator, so look by looking at it, there's two polar forms, which is easier to solve because you just simply multiply 8 times square root of 29, and then the angles you just simply add them. Okay, so that's the rule for multiplication. Now for the denominator, you have the additions. So very simple, you just add the real numbers and then also the imaginary numbers. So that's it. So we have here, so 8 times square root of 29, and then the angle tangent inverse of 5 over 2 is 68.2 plus 10 degrees. Okay, so that's the rule for product if you are in polar forms. And then the denominator, you have 2 plus 2 cosine negative 40. Okay, so that's 3.53, and then j4, and then j2 sine negative 40 is j2.71. Now, so we have two complex numbers, the numerator and denominator. Now, we have learned in the previous videos also that if you are dealing with division, so you convert into polar form. But no one can stop you also to multiply the numerator and denominator by the conjugate of the denominator, okay, and then you will get the rectangular form way. Okay, but the best thing is actually to transform the denominator to polar form. Then you will have this, 4.45 angle 37.5, which is the equivalent of this denominator. Okay, and then so you just simply divide the modulus, so 8 square root of 29 divided by 4.45, and then the angles you just simply subtract from the numerator, which is 78.2, and then by the denominator, which is 37.5 degrees. Okay, just simply divide this and then subtract, then you will have this value. Okay, very good. So then, so this is analytical way. As I said, you can have other method, but basically you start from here. Okay, and you can have other analytical way. As I said earlier, you can solve this one using rectangular form and then this one in polar form. But this one is the most convenient, okay, way to doing. So if you are multiplying or dividing, convert it to polar form. If you're adding or subtracting, convert it to rectangular form. Okay, now as I said, we can use our calculator here. Okay, so we have a calculator here, and then we can solve this one using our calculator very easily. Okay, now take note, you have the denominator. Okay, sorry, I think this one again. So you have plus. So as we start in the first step, no, the one here in the converted. So all the exponential trigonometric form you transform into polar or rectangular form, either polar or rectangular form. So the 8e to the j 10 degrees, you convert that one into polar form, so you can solve it. So because the calculator cannot solve exponential or trigonometric complex number form. Okay, so then you have 2 angle negative 40. Okay, so just to make sure that you are in a degree mode, and yeah, just and then also in the complex mode. Of course, you cannot go to the complex mode, or you cannot use the I, imaginary number, without dealing with the complex mode. Okay, so press enter. Okay, you can see here by default we are in the rectangular form. Okay, so 7.33 plus 6.3, the imaginary number. But you can convert this one into polar form, so from our previous lecture. So if you missed that one, so I'd like you to see that video. So basically you shift 2 and then press number 3, convert that one to polar form, or you can do it manually. Okay, so our answer here is similar to, close to the analytical answer. Okay, so that's sorry, that should be 9.66. Okay, so anyway, so this is the problem here, is the significant figures. Okay, so that's it. This is for the first problem of the one of the challenging problem for complex numbers. So basically the challenge here is to convert the trigo or exponential form into rectangular and, or sorry, either rectangular or polar form, so that you can easily solve them. Okay, that's it.